Okay, in this example of differentiation, we're going to look at what's known as the chain rule, or the function of a function. Now, there are two ways of doing the chain rule, and one of them is very quick indeed. And what I'm going to do is I'm going to show you both methods, and I'm going to explain to you why both methods, that you need to know them. Okay, so first of all, what does it apply to? Well, a sort of a complicated expression would be something like y equals 4x to the power of 3 plus 7 all raised to the power of 10. Now we could differentiate that by expanding out the brackets, well, 10 times. That would be a lot of work, and more than likely you'd make mistakes through it anyway. So there has to be a way of doing it. So what we do is we look at what's inside the brackets. And so we say that y equals u to the power of 10. It's actually u of x, it's y of x, and so on. So where y is equal to u to the power of 10 and u equals 4x to the power of 3 plus 7. So the u is just equal to what's inside the brackets. And what we say is that dy by du, so du, what we're doing is differentiating y with respect to u. So that's equal to, well, the power is 10, so 10 u, and we subtract 1 from that index, comes 9. U is equal to 4x to the power of 3 plus 7. So du by dx, so we're differentiating u with respect to x, so du by dx equals, differentiate 4x cubed, you get 4 times 3 is 12x, and reduce the 3 by 1 to give you a 2, so it's 12x squared. The 7 goes to 0. You differentiate a constant, it just goes to 0. So the rule is that dy by dx equals dy by du times du by dx. So dy by dx equals, so dy by du was equal to 10u to the power of 9, so I'll just write that in, 10u to the power of 9 times du by dx. So du by dx is equal to 12x squared. And now what I'm going to do now is I'm going to replace u with the contents of the brackets, which was 4x to the power of 3 plus 7. So now dy by dx equals 10 on 4x to the power of 3 plus 7. So you can see I've just replaced the u with the 4x plus 7 to the power of 9 times 12x squared. I'll just tidy that up. Dy by dx equals 120 x squared times 4x cubed plus 7 all to the power of 9. And so that is the answer. So when you differentiate y equals 4x to the power of 3 plus 7 to the power of 10, you end up with 120x squared on 4x cubed plus 7 all to the power of 9. Now, the other way of doing it is that, we'll just take that same example, y equals 4x to the power of 3 plus 10 all raised to the power of 10, sorry, not 10, 7 all raised to the power of 10. So what we do is we say that dy by dx equals, first of all we take the power, we write it down, times. We look inside the brackets and we say, what happens when we differentiate inside the brackets? Well, when we differentiate 4x cubed, we get 12x squared. When we differentiate 7, it goes to 0. So we're just left with 12x squared on. We now write down the contents of the brackets, 4x to the power of 3 plus 7. And this time, for our original index of 10, we reduce it by 1 to a 9. So dy by dx equals 10 times 12 is 120 x squared on 4x cubed plus 7 all to the power of 9. Now you might be wondering, well, why did I do the dy by dx equals dy by du times du by dx? Well, believe it or not, within what we've just done here, that's actually what you're doing. But we're just taking some shortcuts. But where the dy by dx equals dy by du times du by dx is really important is when we're dealing with trigonometric functions. That's when you really need to be able to substitute for the value of u. So let's take an example, another example now. So we'll get y equals 9x to the power of 7 minus 3x squared to the power of 6. Okay, so dy by dx equals, so we write down our 6 times. Now we're going to differentiate inside the brackets, but you can see there are no constants inside the brackets, so they've both got the variable x. So I'm going to put them in brackets. So when I differentiate 9x to the power of 7, I get 9 times 7, I'll just put that down, 9 times 7 x, and reduce the 7 by 1 to give me a 6, minus 3x squared. When I differentiate 3x squared, I get 3 times 2x to the power of 1. Okay, now that's the inside of the brackets differentiated. Now what we do is we write down the original contents of the brackets, 9x to the power of 7 minus 3x squared, but this time we reduce the power of the index by 1, so 6 goes to 5. So I'm going to tidy this up. Dy by dx equals 6 on 9 sevens are 63, I almost forgot, to the power of 6 minus 3 2s are 6, x, and because it's to the power of 1 we just write it as x. And then the final bracket, 9x to the power of 7 minus 3x to the power of 2 all to the power of 5. I'm just going to leave that. That is good enough. We'll take a third one. Y equals 5x to the power of minus 3 plus 2x to the power of 4. dy by dx equals, we write down the 4. We now differentiate inside the brackets. 5 times minus 3 is minus 15 x. Minus 3 minus 1 is minus 4. Plus, differentiate 2x, you get 2. We now write down the original contents of the brackets. 5x to the minus 3 plus 2x. And we reduce the power from 4 to 3. Does that tidy? Oh yeah, I suppose I could. Dy by dx equals, well, see that 2 minus 15, I'm just going to swap the 2 over and the minus 15 just to makes it easier to read. 4 times 2 is 8, it's inside a bracket. 4 times 15 is 60, so minus 60 x to the minus 4 on 5x to the minus 3 plus 2x all cubed. So that is the chain rule.